Hey guys, I am going to go ahead and answer some of these questions in case you're having any troubles out there. And I'm not going to do the whole thing. And in fact, I'm going to do more than I'd ask you to do. But just anyway, let's jump straight into this. Number one, if I was going to solve this, now I realize that you probably could potentially do this in your head, but I'm still going to solve it as if I needed to show 100% of my work. I'm going to subtract 7 from both sides because I'm trying to get p by itself. These 7s cancel, leaving me with p equals negative 16. Now that p is by itself, that's the answer. Number 4, g plus negative 3 equals 4. If you'd like, you can write this as g minus 3 equals 4. And then you can just add 3 to both sides, and you get that g equals 7. Let's do a couple more over here. How about this one? I like this one because it's backwards from maybe how you're used to writing things. And if you're like, what do you mean backwards? See how over here we had our variables on the left, variables on the left. This one, the variable is on the right. And that doesn't mean anything. Not really, nothing new. What we're still going to do is subtract 1, and that cancels, and that means w is equal to negative 11. And there is absolutely no reason to rewrite it any other way, because that is still a very complete answer. Now, I know that I wrote on your pages to check every third problem. So let's do that. How would I do that? I'm going to take this negative 11 and I'm going to plug it in for w, because the idea was right here, you don't know this guy's name. Down here, you know his name. So you no longer have to refer to him as w. You can refer to him as negative 11. So we'd have negative 10 equals negative 11 plus 1. Well, so negative 11 plus 1 is negative 10. And does negative 10 equal negative 10? It sure does. Smiley face. Yeehaw. All right, I think that's enough of those right there. Let's check out down here. All right, number 8 is kind of like one we did in class, but not exactly. We want to get t by itself. What's happening to t is it is being divided by negative 3. It is also being added to by 4. And so according to kind of what I told you in class, I want to solve by doing the opposite. And that means I'm going to deal with the adding and subtracting first. So let's subtract 4, because that is getting things away from the t. Now, if you're like, that's not what I would have done, I'll show you another way here in a second. So these 4's cancel, leaving us with 8 minus 4 is 4. And t over negative 3 is still there. Now, we are done with adding and subtracting, because right here, there is a t not being added to, but being divided. So what is the opposite of being divided? It is multiplying by negative 3. And so these negative 3's cancel, leaving us with t is equal to negative 12. Now, I said I'd show you another way, so let's do that real quick. 8 equals t over negative 3 plus 4. I wouldn't do this way most of the time, but I figured I'll show you what is an alternative thing here, is you could multiply by negative 3. And if you're like, wait, why are you putting negative 3, why are you putting parentheses here and here? Because here's what's going on. When I subtracted this 4, believe it or not, I'm subtracting 4 from this entire side. It's just that it only affects that 4 right there. So if I were to multiply by 4, I'd have to multiply the entire side by 4, and that's why we have parentheses here and here. So let's now distribute that negative 3. And if you're like, why did he pick negative 3? Well, because it cancels this negative 3, giving us just t. But I can't forget to distribute it right there, and it's now negative 12. Since I did it to this side, I have to do it to this side, and I get negative 24. And now I add 12 and I get that t equals negative 12. And that's what I got before. Again, I would not do this normally, but I thought, you know what, let me go ahead and show you what you could have done. Okie dokie, okie dokie. So number 9, p plus 5 divided by negative 2 equals 9. Again, I'm gonna write this over here just as to kind of remind you, hey, start here, do the opposite. Can I do the adding and subtracting right now? Well, the answer is not exactly. The answer is I could if I were to start here and simplify it first. I can't write. We'll just pretend this says simplify. Okay, and here's what I'm gonna do real quick. I'm gonna copy paste this problem. Nothing happened. There we go, that happened. So that I can do it again right here. So what I'm gonna do first is do the way that I recommend. I'm going to multiply both sides by negative 2. And what happens is this negative 2 cancels that negative 2, and I get p plus 5 equals negative 18. And then I'm going to subtract 5, and I get p equals negative 23. Not too bad. But what if you thought, I really don't want to multiply by negative 2? Then here's your option. P is being divided by negative 2, and 5 is being divided by negative 2. So we have p over negative 2 plus 5 over negative 2, and that equals 9. So now we have, this red part isn't going to change, p over negative 2. This blue part is kind of a bummer because 5 over negative 2 is really negative 2.5, right? And that's not bad. And if you're a fraction person, it's negative 2.5, and that still equals 9. So okay, I have now simplified, which is what I was saying up here. I've simplified this now as much as I can, and so now I am ready to start solving by doing the opposite. And now I really can start by adding. And I get p over negative 2 equals 11.5. And then I will multiply both sides by negative 2. And it's kind of funny, I will get negative 23, but this just didn't seem like that's how it was going to end up, did it? And now let's be honest. Right here, there was 2 steps. Here, there was 1, 2, 3, 4 steps. I don't know. I think I'd rather do 2 steps than 4 steps. All right, these last ones, I'm just going to pick one of them. And I feel like let's pick 12 right here. It's kind of the most by itself down here. This is not a real tricky problem. In fact, it's as tricky as these up here. It just needs to be simplified first. And I told you when I wrote PEMDAS on the board that you always, and I said always like a handful of times, you will always technically think through, can I simplify this problem before you do anything? So can I simplify? Yeah, I can add these two. I get 28 equals 21b minus 35. I can add, and okay, I'm getting ahead of myself a little bit. I have simplified it now, right? And so now I am down here to start solving and start with the adding and subtracting. I'm going to add 35. Gone. And then I get 63 equals 21b divided by 21 divided by 21. And I get that b equals 3. So this is one where technically, hey, it's a third problem, so checking your answer is important. So, okay, we're going to take this 3 and put it here and put it here. So 28 equals 8 times 3 plus 13 times 3 minus 35. And what does that look like? Oh, I'm going to kind of zoom in here. I didn't budget for my area, sorry. 24 plus 39 minus 35. Well, the way I kind of like to do my adding and subtracting is, these guys are kind of close to each other. 39 minus 35 is 4. And 24 up there, 24 plus 4 is 28. So I have now checked my answer. I am correct. So I think you guys can handle those. Let's slide to the back. You know, I didn't do the word problem here, so here, let's do one of these word problems. A bill to landscape your yard is $720. I love problems like this because when I see is and then a number, I know that I have immediately an equal sign because that's how totals work. When you buy stuff at Walmart, you scan a thing, scan a thing, scan a thing, and at the bottom is the total. It adds all of it up, all these things, and there you go. So, speaking of things, the materials cost $375. That seems like a very, there's no change to it. $375, and the labor is $34.50 per hour. That sounds like it could change. So $34.50 times H for hours. You could do T for time, you could do X, I don't really care. And by the way, I kind of cheated in that I already know how to do this. I know that I'm going to write and solve an equation to find the number of hours of labor spent on the landscaping job. So I've done that. And now this is just like those other problems. Subtract 375, subtract 375, and I get that I've run out of room. So 3450 H equals, let's see, 720. So here, let me give you another little insight into McMath. So 375, if I add 25, that's 400. And then I just have to get up to 720. So that's another 320. So this is 345. 345. 720 minus 375 is 345. And if you're like, how did you do that? I took that 25 and I took that 320 and added them together. Okay, so now I will divide by 3450. 3450. And here's the thing. I would have to multiply this guy by 10 to get 345. And so the hours are 10, because if that didn't make sense what I just said, 345 divided by 34.5, that means there's 10 of these for one of those. So the answer is just 10. Okay, sorry if that was confusing. Down here, I'd ask you to go to 18, and so that's what I'm going to do right now, is why don't we just jump to 18? All you got to do is simplify first. So here, I'm in the habit of saying simplify. So technically, like I said, you always start by thinking about simplifying. Well, I'm going to distribute 6. And if you're like, wait, I didn't know that. Well, I can't actually do what's inside the parentheses. There are no exponents. And distributing is multiplying. So 6 times q is 6q. 6 times negative 7 is negative 42. And negative 3 times 4 is negative 12. Negative 3 times negative q is positive 3q. And that equals 0. Okay? I'm still simplifying because I'm done. But I'm not done with these. So 6q and 3q is 9q. And let's see, 42 and 12 is negative 54, and that equals 0. I'm going to add 54 to both sides, and I get 9q equals positive 54. Divide by 9, and q equals 6. Oh boy, this is one that I'm supposed to check my answer, so let's do that. Let's take that 6 and plug it in here and here. So actually, let me not be lazy and let's write them out. 6 times 6 minus 7 minus 3 times 4 minus 6, that equals 0. So according to PEMDAS, I'm actually going to do the parentheses first. So I get 6 times negative 1 minus 3 times negative 2, and that still equals 0. 6 times negative 1 is negative 6. Negative 3 times negative 2 is plus 6. Does 0 equal 0? It sure does. So I'm pretty sure that if I were to lock you guys in a room and say, do these 4 problems, you could do them. But here's what I'm not going to do. Since I didn't technically go over it in class, I am going to go ahead and just wait and see how things work for you, or teach it, and you know what, let's just talk about it later. All right, guys, see ya.